Okay, let's see. So this is regarding the TMOD. This is a 8-bit ka register. Fine. Now, as we have seen here, these 4 bits are repeated over here. The same 4 bit we are having over here. Okay. But what is the difference in this one? Okay, these are the lower 4 bit which we just control timer 0, and these are the higher 4 bit that used to control timer 1. So means what? If I do any changes in this lower 4 bit, means what is going to affect the timer 0 ka setting. Fine. And if I do any changes in this upper 4 bit or upper nibble, it will affect timer 1 ka setting. Okay. Now, what is the use of this particular bits? Let's see. Now, the gate is a bit. So it's a single bit. So it can be either 0 or 1. Take a gate is a bit which is a single bit which can be either 0 or 1. Now, this will decide who will start the timer, whether it is externally interrupted or not. Are you getting it? So whether we require an external interrupt to start the timer or not, that will be decided by the gate. Getting it? So whenever it is a 0, external interrupt is not required. Whenever it is a 1, yes, external interrupt is required to start the timer. I hope you remember the diagram which I have shown in the first lecture. So let me just take you to the diagram first of all. So this was the diagram we have seen in first lecture of timer. Now, this particular gate bit, now you can see this particular gate. Now, this particular gate bit is controlled by that TMOD ka first bit, that's a gate. Fine. So now if that gate is equal to 0, if the gate is equal to 0, means what? This is applied to the NOT gate. So here we'll be getting a 1. And as this one is an OR gate, so if you're having a 1 entry as a 1, so output will be the 1. Okay. So timer will be entirely controlled by this TR bit. So we do not need any external interrupt to on this particular timer. I hope you are remembering it. Fine. So gate bit will decide whether to start the timer by means of external interrupt or not. Fine. So if the gate bit is equal to 0, yes, we will just adjust by using this TR bit only. We do not need any external interrupt. But if gate bit equal to 1, then here you can see that NOT output is going to be the 0. And to make this particular OR output 1, we need to give that interrupt over here. Getting it? So in that case, this timer will be driven by external interrupt. Fine. So the gate bit will decide who will on the timer. External interrupt karega ki nahi karega. That will be decided by the gate bit. Okay. Then we are having another bit which is the C oblique T bar. This is that bit. Okay, which is we have seen here in register. Okay, so gate ka use to decide whether to start the timer by external interrupt or not. Fine. If it is a 1, yes, we need external interrupt. If it is 0, we do not. Fine. Then we are having C oblique T bar. So C oblique T bar means what? Now this is what this will decide whether to use a timer as a counter or a timer. Now, whenever I say I have to use a timer as a timer, means what? That count will be incremented because of derived frequency from the crystal oscillator. Or you may say this is an inbuilt frequency. Getting it? And if I want to use a timer as a counter, now that count will be incremented or will be affected because of external frequency. And that this particular bit is actually attached over here to this particular switch. This particular switch. So this switch is like C oblique T bar. Okay. If it is a 0, it will select the frequency or the clock pulses which will affect the timer. That will be from the crystal oscillator. That will derive from the crystal oscillator. I think I have told you why to divide by 12. Getting it? So that frequency will get divided by the 12, and now that will be given to the timer so that the count will get incremented. Whenever the C oblique T bar is equal to 0. Fine. And now if you want to use that timer as a counter, then in that case you have to make this particular bit C oblique T bar is equal to 1 so that this particular switch will be toggled down and it will select the external frequency which we have to apply at pin 3.4 and 3.5. If you remember, we have seen the port number 3 in which the 3.4 and 5 therefore the timer 0 and timer 1. Getting it? That T0 and a T1. So here you have to apply that appropriate frequency. If you're dealing with the timer 0, then you have to apply the pin number 3.4. If you're dealing with the timer 1, then you have to apply at pin 3.5. Fine. So this is the use of C oblique T bar. So this is actually used to select the frequency or the clock pulses ka source, whether it's an inbuilt or an external. If it is an inbuilt, it is called as a timer. If it is an external, it is called as counter. Fine. So that is what is the use of this C oblique T bar. And then we are having next 2 bit, that is a mode 1, that is M1 and M0. So M1 and M0, now these are the 2 bit which are actually used to select the mode of the timer. Okay, they are actually used to select the mode of the timer. So now here we can see we are having 2, that is M1 and M0, means what? So by means of this 2 bit, we can have the 4 mode of timer. Means what? We can just have the combination as 0, 0, 0, 1, 1, 0 and 1, 1. Getting it? So whenever I just keep this particular setting or this particular bits as a 0, 0, my timer will be working in a mode 0. Now, what do you mean by mode 0? What is the specialty of it? That we will see later on. Okay, so first just understand, now this TMOD is actually used for selecting the mode of the timer, and these are the 2 bits who are actually responsible for selecting the mode of the timer. Now the timer can work in a 4 mode. Why? Because for the selection we are having a 2 bits, so that's why we can support 4 different combinations. So that's why timer can be worked in a 4 different modes. Fine. So here we are having that mode 0, then we are having mode 1, mode 2, and mode 3. And for this particular mode, yeah, these are the setting 0, 0, 0, 1, 1, 0, and 1, 1. Fine. So according to this M1 and M0 bit ka values, it will decide which timer to use in which mode. Okay. So once again, this gate is used for whether to turn on the timer by means of external interrupt or not. That will be decided by the gate. So normally this bit is going to be the 0. Normally this bit is going to be 0. Getting it? Then this C object T bar, this will decide whether to use this particular timer as a timer or a counter. Or you may say it is actually used to decide the source of the frequency. Let's say internal or external. Fine. If it is a 0, means what you use the timer, means source of frequency will be internal. That is derived from crystal oscillator. And if it is a 1, the source of the frequency will be external. That is, we have to apply pin 3.4 and 3.5. Okay, then we are having these 2 bits, that M1 and M0. Now they are actually responsible for selecting mode of the timer. Getting it? So here we are having mode 0, mode 1, mode 2, and mode 3. So this is what the setting we have to do. And similarly, the same bit, that functionality will be available over here for the timer setting. So the difference is that if I do changes over here in the lower nibble, then it will affect timer 0. And if I just do changes over here in the upper nibble, then it will just affect the timer 1. That's it. Fine. So this is what the TMOD is all about. So this is what is the structure for the team. Okay. Now you tell me, let's suppose what I want to do is that what user want to do is that I just want to use a timer 0 in mode 2. I just want to use a timer 0 in a mode 2. So what to do or what to place in a TMOD so that my timer 0 will be used as a used in a mode 2. I hope you are getting a question. Once again, what I want to do is that I just want to use a timer 0. Okay, and that I just want to use it in mode 2. So what value you have to put in this TMOD so that it will just do that required function? Yes, come on. Yes, anyone? I want to use a timer 0 in a mode 2. What to do? Where will you change? Whether in a lower nibble or upper nibble?
Oh, one.
Yes, lower. But what value to put? Which bit to change? Acha, what will be this bit? M0. M0, this value you have to just keep it as what?
0.
Just be louder.
0.
Yes, 0. This one, this particular bit.
1.
Yeah, 1. Okay. C oblique T bar. We have, it has been said that you have to use the timer. So this particular bit should be
0.
0. And the gate, if nothing is mentioned, you have to just put it 0. If there nothing is mentioned regarding the bit, then by default you have to place a 0 over there. Okay. So 0, 0, 1, 0. Fine. And it is just regarding the timer 0. So that's why we can just put this particular bit as a 0, upper bit. Because they belong to the timer 1. And nothing is said about the timer 1. So you can just put it as a 0. Okay, so here now try to understand. Now this is the value which you have to load it in TMOD. That is a 000 over here and 0010. Means what? In short, this becomes 0 to H. Fine. So how we will do? It's just like move TMOD comma hash 0 to H. Now whenever I place 0 to H in the TMOD, then 805 will understand. Arey, ha, user want to use a timer 0 and that too in a mode 2. Are you getting it? Understood? Yes or no?
Yes, sir.
Okay, okay. Now, likewise, what do you mean by this byte address page just like this one? Now, in this, I just want to use the timer 0 in a mode. Okay, so what we have to do is that to do that, we have to just get that all the fields, we have to just put that all the fields zeros and 1 appropriately. Okay, and then we have to just get that 8 bit ka value, and then we are just placing into the TMOD. That is what is called the byte addressable. Okay, but if you observe over here actually we just need to change only one bit, that is this particular M1. This particular bit only we have to just make it as a 1 and the rest of the bit will be the 0. So this is what we want to change. ठीक है. And if you try to just make this particular bit as a 1, so this is not possible in case of TMOD. Why? Because it's a byte addressable. Though you have to change only single bit, then also you have to get that entire 8-bit ka value or entire that byte ka value, and then that can be replaced into the TMOD. So here you cannot say that set BM1. That is not possible. Why? Because TMOD is not bit addressable. Getting it? ठीक है. And this is what is possible in case of TCON. TCON में you can use the set B and CLR, but इसमें नहीं use कर सकते. Why? Because this one is a byte and this one is a bit as well as byte addressable. Fine. ठीक है. So that is regarding a TMOD. Now just come. First of all we just finish this TCON and then we just see which are these different modes are. Fine. Now just see TCON. Let me just. This is the TCON structure. Yeah. So as a name suggests, TCON is what timer control register, and this one is a bit address. We can just go to a single bit of it and we can just change it like 0 and 1. Fine. So if I just say TCON, the slide is at 345. Let's see the structure for it. So once again, it's of 8-bit. It's a 8-bit. You can say TCON is a timer control register 8-bit. Okay. And here we are having the bits like this one, that TF1, TR1, TF0, TR0, IE1, IT1, IE0, and IT0. Getting it? So now this lower 4-bit means what is IE1, IT1, IE0, and IT0. Okay, they are actually for interrupt. They are actually for interrupt. They do not have relation with that. I will not say that they don't have relation with the timer, but they are actually for an interrupt. They are not for a timer. Getting? They are actually for a time interrupt. Fine. So IE means what? External interrupt present है कि नहीं उसके लिए. And IT means what? What is the type of that interrupt? So IE means external interrupt, whether it's available or not. So that will be decided with this particular bit just by making 0 and 1. Okay. If this particular bit is 0 means what? External interrupt is not present on INT1. This IE1 means what? This is for the INT1. INT1 is a pin in at port number 3. Okay. Likewise, this IT means what? This is the type of interrupt. If it is a 0, then it is a low level. If it is a 1, then it is a negative edge. Okay, so we will not go in details of this particular one right now. We'll see it later on whenever it comes in picture. Okay, but that is what is the use of this one. So this is for the INT, this 2-bit there for the INT1 and this 2-bit there for the INT0. Keep in mind INT1 and INT0, these are the two hardware interrupt pins which are available on port 3. I hope you remember that diagram, pin diagram. उसमें दो pins है वो. ठीक है, and these 2 bits will test regarding that. मतलब first of all I means what? External interrupt present है कि नहीं, and IT अगर present है तो उसका type क्या. अब type दो होते हैं, एक तो low level नहीं तो negative edge. So that will be decided by this particular bits. Fine. हाँ, now अपने काम की चीज ये upper वाले 4 bit. That is what of our interest. Okay, why? Because now this TR and TF, these are what the flags or the bits which will come in picture while programming the timer. Okay, wherein this TR is what is a timer run. TR is a timer run. ठीक है, इसको एडिट करने को नहीं देता क्या मुझे? बस बेटा, I just try to edit करने को देता है क्या? Let me check. ठीक है, so this TR bit, this अरे हाँ हो रहे हैं. I don't know, some problem. So TR bit is for the timer run. So whenever this particular bit is a 0, now keep in mind we are having TR1 and TR0. So what is the difference? Simple. TR1 is for the timer 1 and TR0 is for the timer 0. Fine. TR1 is for the timer 1 and TR0 for the timer 0. Now TR means timer run. Now what do you mean by the timer run? Once again, come to this 347. So this is what is the use of this timer run. So this is a TR. Okay. So when the timer bit is the TR bit is equal to 1, then it will just place this particular switch down. अब your frequency timer को apply होगा. ठीक है, so then only that the particular timer will run means what? It will start incrementing. Timer run मतलब क्या होता है? उसका count increment होना चालू करेगा. जैसे आप stopwatch रहता है and when you press the stopwatch का button, that will start incrementing that second का जो भी count है फटाफट increment करना चालू करेगा. ठीक है, so that will be done by this TR. TR means what? Timer run. Getting it? So whenever I just make it equal to 1, then we just put this switch down and जो भी clock pulses आने वाले that will hit to the timer and एक एक जैसे clock pulse आएगा rising edge of the clock pulse, it will just increment the count. Fine. So this is how it works. Okay. So TR1 it is to run the timer 1 and TR0 it is to run timer 0. So timer 0 को particular clock buses पहुंचाने के लिए. Fine. So that is what is the use of timer TR. Fine. And then we are having a TF as well. Yeah, we are having a TF. Now TF is what? Is a timer overflow flag. अभी ये समझो, ये भी बहुत important है. ठीक है. TR is for what? To just run that timer. Timer को चालू करने की बंद करना है. Fine. Or to increment that the count or not. And TF is for what? Is overflow. To show that overflow. Timer overflow. This TF means for timer overflow. ठीक है. So what do you mean by this timer overflow is? Let's see. So timer overflow means what? Now let's suppose if I just put some count as a FF F0 something 60 मिनट का काउंट मैंने पुट किया टाइमर में. ठीक है. दैट इज इन TH एंड TL मैंने पुट किया. ठीक है. एंड इफ आई जस्ट से कि सेट बी TR मतलब TR को मैंने चालू किया. लेट्स सपोज TR0 टाइमर 0 में, तो TR0 को मैंने चालू किया. ठीक है. सो व्हाट विल हैपन व्हेनेवर आई से सेट बी TR0 मींस व्हाट टाइमर विल गेट ऑन. टाइमर विल गेट ऑन मींस व्हाट नाउ द क्लॉक pulses will start hitting this particular count. ठीक है. एंड ऑन द एवरी राइजिंग एज it will just keep on incrementing. So FF F0 will become FF F1. Then this will become FF F2. अभी ये टाइमर चालू हो गया, मतलब एक एक इंक्रीमेंट होना चालू हो गया. ठीक है. So it will just go up to the FF FF. It will just keep on incrementing and it will just go up to the FF FF. ठीक है. And इसके बाद भी इंक्रीमेंट होगा because clock pulses तो continuous चालू है, वो तो continuous आ रहा है. Getting it? ठीक है. Now whenever that next rising edge hit to this particular counter, when that value is FF FF, now what will happen? It will just do that FF FF plus 1. Now, if I do FFF plus 1, what will happen? If I do FFF plus 1, what will happen? Yes, guys, if I do FFF plus 1, then what will happen? Come on. If I do FFF plus 1, if the next rising edge head to this timer. Yes, what will be the count next? Come on. From that FFF0, it just because of this continuous pulse, it reaches to the FFF, and then once again one more pulse comes to the timer. Then what will happen? Just do the addition now. FFF plus 1. What will be the count? What will be the number in hexa? Yes, anyone? What will be the count? क्या आएगा? Just tell me. FFF plus 1.
10000.
Actually going to be 100. Okay, but now my timer is going to store only this much because I can store only 16 bit. Are you getting it? It will not store this one. Okay, so after FFF, once that particular clock was that rising edge of the clock was hit to the timer, so that actually the count should be logically should be 10000. But as my timer is of 16 bit only, so it can store only this much. So means what? Now the new value which is there in the timer is called is will be 000. Okay, and whenever there is a transition from FFF to 00, or you may say the all ones to all 0, because FF means what? 1 now, 1 likewise. Okay, so whenever there is a rollover, or you may say whenever the transition from all 1 to all 0, that is called as an overflow. This is termed as overflow in a timer. Okay, so jab all ones to it becomes an all 0. Means what? Jab plus 1 karenge, so all these ones become all 0, and this is called as overflow. And at this time, my TF flag will become 1. So whenever there is an overflow, then my TF will be 1. Getting it? Keep in mind, initially my count was FFF0. It has got incremented to FFF1, FFF2. So all that time up to this FFF, from FFF0 to FFF, my TF will be 0. Because अभी तक overflow नहीं हुआ. Overflow means what? It's just like means all ones should turn to the all 0. That is called the overflow in a timer. Fine. So from this FFF0 to FFFF, जब तक ये increment हो रहा है, my TF flag will be 0 only. But whenever it goes from FF to 00, my TF will be 1, indicating कि timer खत्म हुआ करके. समझ में आ रहा है? So that is what is the use of this TF. Keep in mind now this TF will made 1 by 8051. So whenever there is an overflow 8051 अपने आप it will just make this TF is equal to 1. We are not making it. Try to understand. We are not making this TF is equal to 1. It's an overflow flag. This will indicate कि हाँ अभी timer overflow हुआ है करके. ठीक है? But to make it 0, we want to do it. We have to do it. Okay, that one, this TF will be 1 because of 8051. That 8051 will make it 1 whenever there is an overflow in a time. Getting it? But if you want this back to the 0, then you have to do it by using instruction. So keep in mind, this TF flag will be 1 because of 8051. But if you want this to be the 0, then you have to do it by using instruction. Samjho. ये 1 अपने आप हुआ है because of this situation. You are not written any instruction to make this TF is equal to 1. Getting it? Okay. So this is the one because there is an overflow in a timer and अपने आप 8051 ने to indicate कि overflow हुआ है, it has made this TF flag is equal to 1. Fine. But afterward, whenever you want to reset it, it's not कि 8051 उसको reset करेगा. No. So TF को 1 करना 8051 के हाथ में और TF को 0 करना अपने हाथ में. समझो. Getting it? ठीक है. So it's not कि you will wait for 8051 to make it clear. No, 8051 will not make this TF is equal to 0. You have to make it explicitly by using the instruction CLR TF. तब जाके वो 0. समझ में आ रहा है? ठीक है. So that is what is the use of TF. And now in a TF we are having two, that TF1 and TF0. So it's simply TF1 is used for a timer 1 and TF0 is used for the timer 0. Understood? TF1 is for that whenever that timer 1 is overflow, that will be indicated by TF1 as a 1. Okay? And whenever the timer 0 get overflow, that will be indicated because of this TF0. Understood? Regarding the TCON. So in a TCON, once again it's of 8-bit. Out of that, lower 4 bit they are for the interrupt. So interrupt में कैसे this IE and IT are important one. ठीक है? And once again we are having IE and IT. So 10 means what? 0 is for the INT 0 bit and 1 is for the INT 1 वाला pin. Fine. So IE means what? Interrupt enable मतलब interrupt है कि नहीं मतलब whether is exist or not. So that will be indicated by this particular pin. अगर interrupt रहेगा तो 1 रहेगा. Interrupt अगर नहीं हो pin पे तो 0 रहेगा. Fine. And IT is for what? Is shows the interrupt का type. whether it's a negative age trigger or a low level trigger. अब ये चीज क्या होता है फिलहाल तो जाने दो, बाद में देखते हैं मैंने डिटेल में. What do you mean by negative age and what do you mean by low level? ठीक है, that is a triggering thing. So this will come in picture whenever we see that interrupt. Fine. Okay. So this is they are the 4 bit there for the interrupt. Now then upper 4 bit they are actually of our use in a timer. Fine. So in this we are having a TF and TR. And for a timer 1 we are having TF1 TR1 and for the timer 0 we are having TF0 and TR0. Fine. Then we are, what is the use of this TR? TR is actually mean that timer run, timer को चालू करने का. Means so that now the clock pulses will start increment in the count. Fine. Clock pulses will start increment in the count. So whenever I make this 1, so जो भी count रहेगा वो increment होना चालू होगा. That is what is the timer का TR का bit का use. Fine. So whenever I say 0, TR0, it is for timer 0. Whenever I say TR1, it is for the timer 1. Okay. And what is the use of this TF? It is just to indicate कि timer overflow हुआ है क्या नहीं. Fine. So whenever there is an overflow means what? All 1 become all 0. Okay. When that all 1 turns to the all 0, so that will be indicated by TF कि बाबा timer खत्म हुआ है. Getting it? And it will just become 1. Now this will be made by 805. And if you have to make it clear, then explicitly you have to write instruction for that. तब जाके वो clear होगा. 8051 clear नहीं करेगा. समझो. Okay. So that is regarding the TCON. Any doubts so far in TMOD and TCON? Because they are very important while programming it. Any doubts so far?
No, sir.
Okay, okay. Now we will see what do you mean by that mode, because we have seen TMOD and TCON 2 registers. Now we know which are the fields in a TMOD is simple gate, C oblique T bar, M1 and M0. And similarly, they are repeated for the timer 0. Okay. And at TCON, we are having TF1, TR1, TF0, TR0, IE1, IT1, IE0, and IT0. Okay. Now let's see what do you mean by that mode 0, mode 1, mode 2, mode 3. Okay. They are also important one. Just a minute. I will change the slide. Okay. So this is what it is, the M1 and M0. So as I told that M1 and M0, these are the 2 bit will decide the mode of the timer. So when it is a 0, 0, what do you mean by this? Mode 0 is what now to try to understand. It's just like it's a 13-bit timer. Now we have seen that timer which are available to the 8051, the timer 0 and timer 1, they are of 16-bit. Getting? But whenever I use this timer in a mode 0, so out of the 16, only 13 will be available. So that's why it's called the 13-bit timer mode. Are you getting it? Now, what do you mean by this 30-minute timer mode? I just want to edit over here only, but कैसे करूँ? पेन को अलाउ नहीं कर रहा है. ठीक है, लेट मी जस्ट कॉपी पेस्ट दिस guys. Yeah, now it will. Oh, good. I think it is visible. Yeah. Let's see. Now, what do you mean by this one? Now I can edit. Okay. Yeah. So whenever it is a 0 0 means mode 0. So mode 0 means what is a 30-minute timer. Now, what do you mean by 13-minute? It's just like as I told that timer 0 and timer 1. They are of 16-bit. Now, how do I say that 16-bit? Because in a timer 0, we are having TH0 and TL0. Likewise, in timer 1, we are having TH1 and TL0. TL1. Okay? And both are of 8-bit. Fine. Now, when I use this particular mode, there is a mode 0. Means just if I just go to the TMOD and if I just set like a mode 0. Fine. So in that case, what happens is that now you can see over here, 8-bit timer counter THX with TLX as a 5-bit. Means what? So that TH0 will be fully available. Means I can just use all the 8-bit of the TH, but out of that TL is actually of 8-bit, but out of that 8-bit I can use only 5-bit. समझ में आ रहा है? Getting it? Okay. So though my timer is of 16-bit, but out of that we can use only 13-bit. Getting it? And 32-bit because the division is like this one. From TH you can use entire 8-bit, but from the TL you can use only 5-bit. Are you getting it? Okay. And if you want to see the operation actual में कैसे होता है, मतलब whenever I use this one तो होता कैसे? It's just like this. Let's see. समझो अभी I will just give the idea. Though you not get the entire thing, but थोड़ा बहुत आइडिया आ जाएगा इससे. ठीक है. अभी क्या होता है देखो. अभी इधर से क्लॉक बसेस आ रहे हैं. समझो. I'm just using timer 0 in a mode 0. So what happens? Let's see. Okay. So these are the clock pulses which are reaching the timer. Okay. Now what is the use of this particular pulse is that जैसे एक एक pulse आएगा और pulse में तो जैसे इसका rising है जाएगा, this count will get incremented. ठीक है. अब होता कैसे? Let's see. It's just like first it will increment TL0. समझो. पहले देखो दोनों में count लेस वो 0 0 है. समझो अभी. ठीक है. First that now this pulses will be given to the TL0 and उसके बाद the TL0 will affect the TH0 and उसके बाद इधर TF रहेगा. समझो समझो समझो. ट्राई टू अंडरस्टैंड क्या हो रहा है. ठीक है. दिस इज व्हाट आई एम जस्ट टेलिंग यू द इंटरनली क्या होता है. ठीक है. दिस इज एक्चुअली नॉट रिक्वायर्ड, बस knowledge point of view you must know, nothing else. Fine. So now let's suppose these are the clock pulses which are hitting to the timer. Now what happens actual में होता क्या है कि first of all it will just increase this TL0. Getting? And out of this we are just using only 5 bit. Try to understand. Fine. So मतलब जैसे पहला पल्स it will become 1, दूसरा आएगा it will become 2, 3, 4, 5, 6, 7, 8, 9, 9. Likewise it will go. ठीक है. And it will just count at 32 bit. Why? Because 2 raised to 5 is 32. Getting is 2 raised to 5 is 32. Okay. So means what? Whenever that all 30 pulse comes over that we can say that reach the timer, then here the count will be 32. Means there will be all ones. Okay. All one means so 5 1 will be there. Why? Because out of that 8 bit we are using only 5 bit. So 5 1 will be there. Okay. And after that if I just give one more pulse to this particular timer, let's see what happens. ठीक है. अब जाके ये ओवरफ्लो होगा, मतलब ये ओवरफ्लो होगा मींस +1 होगा मींस नाउ देयर विल बी द 0 0 0 एंड व्हेन TL0 ओवरफ्लो तब जाके TL में एक ऐड होगा, TH में एक ऐड होगा. गेटिंग इट? ट्राई टू अंडरस्टैंड कैसे काम करता है. दिस इज द इंटरनल थिंग. ठीक है. वंस अगेन दिस इज नॉट रिक्वायर्ड फॉर एनीवेयर इन एग्जाम, बट नॉलेज पॉइंट ऑफ व्यू यस यू मस्ट नो. Getting it? So once again, let's see what how this particular mode 0 works. It's just like this one. Okay. So clock pulses will actually affect the TL0, not TH. So clock pulses will keep on incrementing this TL, and it's a 5 bit. Means what? At maximum it can just count 32. Fine. So जैसे clock pulses आएंगे, it will just keep on incrementing. It will just go to the 1 1, and जैसे TL अभी overflow हो जाएगा. So when the TL overflows, then it will increment over here. मतलब TH में जो 0 0 था वो 0 1 बनेगा अभी. ठीक है. उसके बाद once again we just start incrementing, मतलब 0 0 से start, मतलब from this one we start incrementing 0 0 0 0 0 0 1. Likewise up to go to the once again 1 1 1 1. That is once again 32. ठीक है. एंड फिर से ये जब ओवरफ्लो हो जाएगा तब जाके यहाँ पे 2 होगा. ठीक है. सो whenever the TL0 overflows, then TH will increment. Are you getting it? Whenever the TL0 get overflow, then the TH0 will increment. It's not that the clock buses are affecting the TH or they are changing that entire 13 bit का count. No. So they are just affecting the TL0 first. जब TL0 overflow हो जाएगा तब ये TH overflow, मतलब TH increment होगा. And ऐसे overflow होता है, so after some time this TH will also become FF. समझो अभी क्या हो रहा है. TH will become FF. Fine. And अगर उस टाइम पे let's suppose TH0 overflow हुआ, so we just increment this one. अब ये increment मतलब कि ये फिर से 0 0 हो जाएगा. And when the TH0 become overflow मतलब 11200, तब जाके मेरा TF flag 1 होगा. समझो कैसे क्या हो रहा है. Try to understand TF flag कब होगा. So first of all TL increment होगा. TL 3 to जाएगा मतलब 1 1 होगा. उसके बाद वो overflow होगा. जैसे वो overflow होगा, the TH0 will get incremented by 1. ठीक है, this process will keep on repeating till what this TH reaches to the FF. ठीक है, once this TH reaches to the FF, then whenever the TL overflows for the next time, now it will just overflow this TH also. And जब TH overflow हो जाएगा तब जाके TF flag 1 हो जाएगा. Are you getting it? So this is how this particular thing works. Getting it? Okay, so in this particular the mode 0, the maximum count which we can achieve as is of 13 bit means what there will be the maximum 13 1. You have to just draw the 13 times. Okay, so when you draw the 13 times, this 4 4 4 and 1. Okay, so maximum count which can be achieved in this 13 mode is 1 FFF. Are you getting it? So this is the count. So means what? If I initially place 0 0 0 0, this may be 0 0, this may be 0 0. Okay, so maximum it can go up to the 1 FFF. That's it. That is the maximum count which is possible by use of this mode 0. Okay, why? Because in a mode 0 we are restricting to the 13 bit, not to the 16 bit. It's a 13 bit. Okay, and if you have to just find out how much delay is achieved, so it's just like 1 FFF. Okay, into time. Now time will be what? This will be what this particular time means. Now we know when this particular count is getting incremented after every rising edge. So we should know this particular time. What is the timing between the two rising edge? Or you may say what is the time period for this particular square wave or clock pulses. Okay. So that means let's suppose crystal oscillator is of 12 megahertz. So this particular frequency will getting divided by the 12. So what the frequency which is reaching to the timer will be 1 megahertz. Are you getting it? Okay. So actual frequency is 12 megahertz. We are just dividing by the 12. Getting it? Okay. So the frequency which is hitting the timer is going to be the 1 megahertz, and 1 megahertz ka time period if I want to get, that is 1 upon f. So it is going to be the 1 microsecond. Okay. So the maximum time period which can be achieved, or maximum time delay which can be achieved by using a mode 0 will be 1 FFF. It is actually 8192 in decimal. This is in hexa 1 FFF. But if I just calculate in decimal, it's going to be the 8192 into 1 microsecond. अब ये 1 microsecond कैसे निकला? If I just generalize this, so it is going to be 12 divided by f. Because actual frequency which is hitting the timer, there's a timer frequency, will be what f divided by 12. मतलब जो भी crystal divided by 12. Okay, and if I want to get the time, so time will be at 1 upon ft. Now this particular timer frequency. So that's why if I just do reverse of it, it's going to be 12 divided by f. Getting it? So if I just want to have it in generalized, then I can just write 12 divided by f. Getting it? Okay. So the maximum time period or maximum time delay which can be achieved because of mode 0 will be 1 FFF into 12 divided by f. But this 12 divided by f is going to be in time, it's going to be in a second or microsecond, jo bhi hai. Fine. And this is actually I have written in hexa, but if I just convert into decimal, so it's going to be the 8192. So 8192 into this particular, that is going to be the maximum delay which is achieved by using mode 0. Okay, understood mode 0? Any doubt in a mode 0? Please ask. कुछ भी doubt रहेगा तो please ask. Timer is very important. Any doubt?
No,
Come on,
sir.
please ask. Yes. दृष्टि, रिया, कार्तिक, अनिकेत, किसी को भी?
No, sir.
Okay, fine. I hope you understood. ठीक है, so that is regarding the mode 0. Now when we will do the actual programming ना तो ज्यादा समझेगा आपको, don't worry. ठीक है, but यहाँ पे just you must know मतलब फंडा क्या है. Fine. उसके बाद now we are having a mode 1. Now can anyone tell me mode 1 में क्या होगा? Now it's a 16 bit. I have just explained enough regarding the mode 0. Now you tell me what will happen in mode 1. So mode 1 is just it is information like a 16 bit timer mode. अब इसमें क्या होगा? इसमें क्या होगा? Can anyone tell me? Mode 1 में. Now in mode 1 it allows 16 bit ka timer. So what will happen in this case? Anyone? Just guess on this. 16 bit मतलब क्या? And what will be the maximum count? ट्राई टू अंडरस्टैंड दिस टाइमर. अगर नहीं समझ तो प्लीज आस्क, डोंट हेजिटेट. Yes, come on, please answer this one. Mode 1 में क्या होगा? If it is a 16 bit. Now it's similar to the mode 0 but just count, ये 13 bit का, ये 16 bit हुआ है, बस बाकी कुछ नहीं. कोई बताएगा, कोई ट्राई मारेगा? और this one mode 1, how it goes? It's simple. Now in mode 0 what we have done is for 13 bit. So that's why we have used TH का 8 bit and TL का 5 bit. But if I say mode 1,
Both
now
will
the
be of
entire
8 bit.
16 bit is available to me. Means what? I can use
Both will be of 8 bit.
Yeah, so the both will be of 8 bit. समझा? So I can use the TH का also 8 bit and TL का भी 8 bit. ठीक है? बट अभी इसमें कैसे होता है पता है? Now ये जो क्लॉक प्रोसेसर रहेंगे ना, वो एंटायर 16 बिट को इंक्रीमेंट करेंगे. अब ये थोड़ा क्या बोलते हैं 8051 के अंदर वाली बात है, बट ठीक है, थोड़ा बहुत आइडिया देता हूँ मैं आपको. इसके एक्चुअली मतलब दिस वन इज पार्ट ऑफ नॉलेज, प्योर नॉलेज. ठीक है? इन मोड 0 में कैसे होता है? लेट्स सी. मोड 0 में क्या होता है? दिस क्लॉक पल्सेस विल इंक्रीमेंट टीएल, एंड जब टीएल ओवरफ्लो हो जाएगा तब वो टीएच को इंक्रीमेंट करता है. दिस इज हाउ इट गोस. एंड जब टीएच ओवरफ्लो हो जाएगा तब जाके वो टीएफ को 1 करेगा. फाइन. बट इन मोड 1 में कैसे होता है? नाउ दिस क्लॉक पल्सेस विल इंक्रीमेंट दिस एंटायर 16 बिट. समझो, अब ये ऐसे काम करता है. एंटायर 16 बिट मतलब ये 0000 रहेगा इनिशियली, देन इट बिकम 0001, देन 0010 लाइकवाइज. सॉरी 0002. ठीक है, 0003, 004 लाइकवाइज इन हेक्सा. ठीक है, ठीक है. दिस इज व्हाट 8 बिट का काउंट, दिस इज द 8 बिट का काउंट इन टीएच एंड टीएल. तो ये एंटायर 16 बिट को इंक्रीमेंट करेगा. ऐसा नहीं कि पहले टीएल को इंक्रीमेंट करेगा, जब 8 बिट ओवरफ्लो हो जाएगा तब जाकर टीएच को इंक्रीमेंट करेगा. नो, ऐसा नहीं होता है. इफ यू सी इट एक्चुअल ना, ऐसा नहीं होता है. समझो 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 क्या हो रहा है. ठीक है. सो हियर जस्ट डिफरेंस इज दैट इट जस्ट इंक्रीमेंट दिस एंटायर 16 बिट, एंड जब ये एंटायर 16 बिट ओवरफ्लो हो जाएगा, मतलब ऑल FFFF2 00 बन जाएगा, तब जाके मेरा TF फ्लैग 1 हो जाएगा. Getting it? So that is what is the difference in mode 0 and mode 1. So mode 0 में we can use only 13 bit. So 13 bit कैसे? TL का 5 bit and TH का 8 bit. ठीक है? But in a mode 1 we can use a 16 bit, means what TH का भी 8 bit and TL का भी 8 bit. ठीक है? So that's why it was that mode 0 was of 13 bit. So that's why the maximum count which is possible was, sorry, is 1 FFFF only. It's not 1 FFFF. Let's see. Here mistakenly I have written as 4 time F, but it's going to be 1 FFF. 1 FFF. Only 1 FFF. It's not 1 FFF. 4 time F नहीं, 3 time ही आएगा, because it's 13 bit का. Okay, that was my mistake. ठीक है? So it's a 1 FFFH. Fine. So here in a 13 bit, the maximum count is going to be 1 FFF, and in a 16 bit mode, the maximum count will be FFFH, because it's 16 bit का. ठीक है? So अभी now for the mode 1 the maximum time delay will be what? This particular count, that is FFFF into 12 divided by F. ठीक है? So FFF मतलब डेसिमल में कितना होता है? 65,536 जो भी होता है. I don't remember the exact value. Yeah, but this is what I think. 65,536 जो भी into 12 divided by F. ठीक है? So that is going to be the maximum delay which can be achieved by using a mode 1. Getting it? ठीक है? So that is what is the mode 0 and mode 1 we have seen. Fine. So mode 0 13 बिट का होता है, mode 1 16 बिट का होता है. So normally we just use the mode 1 only. Why? Because इसमें 16 बिट का एक्सेस मिल जाता है. मतलब 13 बिट का तो काम हो जाएगा ही. ठीक है? So normally we use the mode 1. Fine. Now the next two are थोड़ा थोड़ा सा different. Let's see. फटाफट. We are having only 10 minutes. ठीक है? So next one, that is the mode 2 is a 8 bit auto reload. Mode 2 is a 8 bit auto reload. ठीक है? Mode 2 is a 8 bit auto reload. ठीक है? Now what do I mean by this one 8 bit auto reload? अभी ये कैसे होता है देखो. Try to understand. 8 bit auto reload mode 2. I'm just discussing mode 2. ठीक है? Which is 8 bit auto reload. ठीक है? अब ये ऑटो रिलोड चीज क्या है? जस्ट लाइक दिस. लेट्स सपोज आई एम टेकिंग एग्जांपल ऑफ टाइमर 0. अब ये कैसे होता है? लेट्स सी. इधर से क्लॉक प्रोसेस आ रहे हैं. फाइन. यहाँ पे मेरा TL रहेगा. लेट्स सपोज TL, एंड यहाँ पे सॉरी TF रहेगा. ठीक है? एंड हियर विल माय TH. समझो अभी 8 बिट ऑटो रिलोड का मीनिंग क्या होगा. दिस इज व्हाट इज 8 बिट ऑटो. ठीक है? अब इसमें कैसे होता है? नाउ इन अ मोड 2 वी हैव टू प्लेस काउंट इन TH. वी हैव टू प्लेस काउंट इन अ TH. समझो, जो भी काउंट रहेगा ना मुझे TH में रखना है. ठीक है? उसके बाद व्हेन आई स्टार्ट टाइमर व्हाट विल हैपन, दैट TH का काउंट विल गेट कॉपी इनटू द TL. Now this particular count will get copied into the TL and now the TL will start incrementing. ठीक है, समझो TL में मुझे एक्चुअल मतलब while writing a program you have to place count into the TH में रखना है. उसके बाद when I say कि start the timer, when I say set bit TR0 वगैरह जिसको भी चालू करना है चालू करेगा. ठीक है, so at that time what will happen is that now from the count from the TH0 will get copy into the TL0. Fine, and after it is getting copied, now it will just start incrementing the TL. And whenever the TL get overflows, it will make this particular TF as a 1. Whenever TL overflows, it will make TF is equal to 1. ठीक है, and जैसे TF is equal to 1 होगा, अब क्या होगा? Now it will reload the count which is there in a TH0. ये फिर से इधर लोड करेगा. समझो समझो मैं क्या बोल रहा हूँ, समझो मैं क्या बोल रहा हूँ. ठीक है, try to understand. I will just make it simple. समझो. ठीक है, let's suppose ये TL है, ये TH है. Try to understand what do you mean by auto reload. ये TF है इधर. ठीक है, ये ऐसा सिस्टम बनता है. सॉरी ये इधर कनेक्टेड है. फाइन, ये पल्स है. ठीक है, लेट्स सपोज मेरे टीएच में लेट्स सपोज मैं आई एम जस्ट कंसीडरिंग ओनली 8 बिट का काउंट और नहीं 4 बिट का है समझो फॉर अंडरस्टैंडिंग पर्पस. ठीक है, 4 बिट का है मतलब इट विल जस्ट गो फ्रॉम 0 टू f. ठीक है ठीक है, लेट्स सपोज यहाँ पे मैंने काउंट रखा है कुछ तो a, समझो a रखा है. ट्राई टू अंडरस्टैंड क्या हो रहा है. ठीक है, सो टीएल में मैंने टीएच में मैंने a रखा है. नाउ व्हेनेवर आई स्टार्ट द टाइमर दैट a विल गो इन हियर, दैट टीएल में जाएगा. ठीक है, एंड जैसे प्रोसेस आएगा अभी a इंक्रीमेंट होगा, ये टीएल का काउंट इंक्रीमेंट होगा. ठीक है, सो a विल बिकम b, देन c, देन d, देन e, देन f बनेगा. समझो, उसके बाद व्हेन द नेक्स्ट प्रोसेस कम इट विल बिकम 0, ओवरफ्लो हो जाएगा. ठीक है, एंड जैसे 0 हो जाएगा ये टीएफ को 1 करेगा. समझो, ओवरफ्लो हो गया. ठीक है, अभी जैसे ओवरफ्लो का होगा क्या, अभी एक प्रोसेस तो चालू है. समझो अभी क्या हो रहा है, प्रोसेस चल. ठीक है, सो नाउ इट विल नॉट स्टार्ट इंक्रीमेंटिंग फ्रॉम 0 अगेन, 0 1 2 3 4 नहीं करेगा. ठीक है, नाउ जैसे ओवरफ्लो का इधर टीएफ हो गया, अब ये ऑटो रिलोड मारेगा. तो जो टीएच में काउंटर फिर से इधर लोड करेगा ए. कीप इन माइंड ओवरफ्लो होने के बाद ये 0 बना था, ओवरफ्लो होने के बाद 0 बना था, बट वंस अगेन इट विल लोड एज ए, दैट इज कॉल्ड ऑटो रिलोड. जैसे ओवरफ्लो हो जाएगा फिर से लोड करेगा काउंट. समझ में आ रहा है क्या? And this facility was not available in a mode 1 and mode 0. उधर जब ओवरफ्लो हो जाएगा we normally used to stop. ठीक है, जब ओवरफ्लो हो जाएगा we normally used to stop the timer by using CLR. ठीक है, and if I do not stop it will start incrementing from the 0. but यहाँ पे 0 से increment नहीं होगा. if you do not stop it will just increment from this count. ये count फिर से लोड होगा, so that's why it is called the auto reload. auto reload. ठीक है, तो जैसे इधर ओवरफ्लो होगा फटाक से फिर से a इसमें लोड होगा and फिर से भी start increment from the a. once again a will become f after some time. f से फिर से 0 बनेगा, फिर से वो tf को बंद करेगा, फिर से ये इसमें लोड होगा. getting it? what do you mean by auto reload? समझ में आ रहा है? I show you the diagram. It goes like this. Yeah, this is what the auto reload. ठीक है, सो मतलब जैसे टीएफ ओवरफ्लो हो जाएगा, टीएफ गोज हाई, मतलब जब इफेक्टिव 0 टीएल जाएगा. ठीक है, तो वंस अगेन दिस टीएच का काउंट विल गेट लोड इनटू टीएल एंड वंस अगेन ये इंक्रीमेंट होना चलेगा. कीप इन माइंड इट वोंट इंक्रीमेंट फ्रॉम 0 0. ये फिर से मतलब जो काउंट है उधर से इंक्रीमेंट होगा. ठीक है, एंड दिस वाज द फैसिलिटी व्हिच वाज नॉट अवेलेबल विद एनी अदर मोड. अब ये 320 में मतलब मोड 1 में वगैरह देखो क्या होता है. ठीक है, सो दिस इज द डायग्राम फॉर द मोड 1 बिकॉज़ हियर वी आर यूजिंग अ टीएच एंड टीएल एंड यहां पे टीएफ है. ठीक है, सो हियर वी आर नॉट मतलब जैसे ओवरफ्लो हो जाएगा, मतलब ओवरफ्लो मींस व्हाट, जैसे मतलब ये 0 हो जाएगा. ठीक है, सो देयर इज नथिंग लाइक टू लोड द काउंट अगेन. सो इफ आई डू नॉट स्टॉप द पल्सेस देन इट विल स्टार्ट इंक्रीमेंटिंग फ्रॉम 0 ऑनवर्ड्स. ठीक है, बट वो इट विल नॉट हैपन इन केस ऑफ मोड 2. समझो, इट विल नॉट हैपन इन केस ऑफ मोड 2. मोड 2 में जैसे ओवरफ्लो हो जाएगा वो रीलोड करेगा काउंट जो कि टीएच में. सो दैट्स व्हाई मैं टीएच को हाथ नहीं लगा दी उधर. ठीक है, दैट्स व्हाई द पल्सेस आर फेड ओनली टू द टीएल नॉट टू द टीएच. यानी ये पल्सेस टीएल को अफेक्ट करेंगे, टीएच को नहीं. ठीक है, एंड जैसे ओवरफ्लो हो जाएगा ये ऑटो रिलोड मारेगा. फाइन, अंडरस्टूड. एंड द लास्ट मोड इज अ टाइमर. देयर इज अ मोड 3 जो ज्यादा यूज नहीं करते. सो लेट मी जस्ट टेल यू वन सेकंड नाउ व्हाट इज दैट मोड. किधर गया वो टाइम? 316. द लास्ट इज द मोड 3. So mode 3 is actually split mode. अब इसमें क्या होता है एक्चुअल में, if I just tell you, we can use only timer 0 only in this mode 3. Mode 3 is for a timer 0 only, not for timer 1. We can use only timer 0 in this case. ठीक है, and इसमें अभी क्या होता है कि we can अभी timer 0 में we are having two. I'm discussing mode 3. So mode 3 is applicable only to the timer 0, not to the mode timer 1. Timer 1 we cannot use in mode 3. ठीक है, अब इसमें कैसे होता है? So now here we can use two separate 8 bit का timers. ठीक है. तो टाइमर 0 में we know we are having TL0 and TH0. So we can use the TL0 for separate count and TH0 for a separate count. Means what? To this one we can just use different frequency, and to this one we can just use a different frequency. We can give a different frequency to count. Getting it? And now whenever this overflows, that will be indicated by TF0, but whenever this overflow, that will be indicated by the TF1. समझो अभी इसमें दो सेपरेट 8 बिट के काउंटर रहेंगे, दो सेपरेट 8 बिट के काउंटर. दैट्स व्हाट इज कॉल्ड स्प्लिट टाइमर. दोनों स्प्लिट करते हैं. गेटिंग इट? ठीक है. तो यहाँ पे आई विल बी यूजिंग टाइमर 0 ओनली. तो टाइमर 0 का TL0 डिफरेंटली काम करेगा, TH0 डिफरेंटली काम करेगा. Fine. TL0 will get incremented because of different frequency, and TH0 will get incremented because of different frequency. Fine. And now whenever the TL0 overflows, that will be integrated by the TF0, and when the TH0 get overflow, that will be integrated by TF1. समझ में आ रहा है क्या? So that is what is a mode 3. So mode 3 is what? 8-bit split timer. That's what is called the 8-bit split timer. So if you just come over here, it is just like split timer. So it's a 8-bit split timer. Why it is a split? Because we are using this TL0 and TH0 separately. And keep in mind here TL0 and TH0 ही आएगा. TL1 and TH1 नहीं आएगा, because timer 1 को allowed नहीं है mode 3 में काम करने का. Fine. So that is regarding the mode 3. Fine. So what we have seen so far, let's see. पहले टाइमर का थोड़ा सा इंट्रोडक्शन देखा आपने लास्ट लेक्चर में, कैसे काम करते हैं. ठीक है. Today we have seen only two resistors, that's the TMOD and TCON. Inside that we have seen TMOD is for actually selecting the mode of the timer, and TCON is for controlling the timer. ठीक है. TMOD में है क्या? कुछ नहीं. गेट C/T1 M1 and M0 and same repeated over here. गेट का काम क्या है कि टाइमर कौन चालू करेगा? एक्सटर्नल इंटरप्ट की एक्सटर्नल इंटरप्ट नहीं करेगा, डायरेक्ट लिसन विद द गेट. ठीक है. C/T1 डिसाइड करेगा कि टाइमर है कि काउंटर है, मतलब फ्रीक्वेंसी सोर्स क्या है, इंटरनल है कि एक्सटर्नल है. ठीक है. एंड M2 and M1 will decide मोड कौन सा है. अब मोड कौन से देखिए, मोड 0, mode 1, mode 2 and mode 3. Mode 0 is for 13 bit. Mode 1 is for 16 bit. Mode 2 is a 8 bit auto reload. And mode 3 is 8 bit split timer. Getting it? Fine. Then we have seen a TCON. TCON में अपने पास दो important bit है, TF and TR. They are having a IE and IT also, but they are for interrupt. So we will not consider this right now. Fine. So TF and TR. So TF is what is a timer overflow. So whenever there is an overflow, means what? All ones to all zero. So that will become 1. And that will be made 1 by 8051, not by me. That will be made 1 by 8051. And इसको 0 मुझे करना पड़ेगा. ठीक है. एंड टीआर इज व्हाट? नाउ टीआर को 1 and 0 मुझे ही करना है. टीआर जो भी बिट है, जैसे टाइमर है, इसको 1 and 0 मुझे ही करना है बाय यूजिंग द इंस्ट्रक्शन. गेटिंग इट? ठीक है. सो व्हेनेवर इट्स अ 1, टाइमर विल रन. टाइमर विल रन मतलब वो एक्चुअल फ्रीक्वेंसी उसको पहुंचेगा एंड विल स्टार्ट इंक्रीमेंटिंग. एंड व्हेनेवर इट विल 0, टाइमर स्टॉप हो जाएगा. टाइमर स्टॉप मतलब ये इसका जो कनेक्शन रहेगा पल्सेस का, उसको निकाल देगा. Fine. So that is all regarding the timer. I hope you understood timer क्या है, timer के modes क्या है, TCON क्या है, TMOD क्या है.
Yes, sir.
In next lecture we start with the programming. Fine. So that's it for this lecture. So bye bye guys and take care. I'm just ending the meeting.